Hello, we are back with a new section of this course, Click-Thru Prediction through Tree-Based Algorithms. In this section, we will be solving one of the most important machine learning problems in digital online advertising, click-through prediction. Given a user and the page they are visiting, how likely they will click on a given ad. We will be herein focusing on learning tree-based algorithms, decision tree and random forest, and utilizing them to tackle the billion-dollar problem. Now we move on to the first video of this section that deals with a brief overview of advertising click-through prediction. In this video, we will explore the advertising click-through prediction and getting started with two types of data, numerical and categorical. Display online advertising has heavily relied on the ability of machine learning models to predict the ad targeting effectiveness, how likely the audience in a certain age group will be interested in this product. Customers with certain household income will purchase this product after seeing its ad. Frequent sports sites visitors will spend more time in reading this ad, and so on. The most common measurement of effectiveness is the click-through rate, or CTR, which is the ratio of clicks on a specific ad to its total number of views. The higher CTR in general, the better targeted an ad is, the more successful an online advertising campaign is. Click-through prediction holds both promise of and challenges for machine learning. It mainly involves binary classification of whether a given ad on a given page or app will be clicked by a given user, with predictive features from these three aspects, including ad content and information. Next one, page content and publisher information. And the last one, user information. Suppose we, as an agency, are operating ads on behalf of several advertisers, and our job is to display the right ads to the right audience. With an existing dataset in hand, taken from millions of records of campaigns running last month, we need to develop a classification model to learn and predict the future ad placement outcome. This small chunk is an example, where number of predictive features can easily go up to thousands in reality. Now let's get started with two types of data, numerical and categorical. At first glance, the features in the previous dataset are categorical, for example, male or female, one of 4 age groups, one of the predefined site categories, whether or not being interested in sports. Such types of data are different from the numerical type of feature data that we have worked with until now. Categorical features, which are also called qualitative, represent characteristics, distinct groups, and countable number of options. Categorical features may or may not have logical order. For example, household income from low, median to high is an ordinal feature, while the category of an ad is not ordinal. Numerical features, also called quantitative on the other hand, have mathematical meaning as a measurement and of course are ordered. For instance, term frequency and the TF-IDF variant are respectively discrete and continuous numerical features. The cardiotocography dataset contains both discrete and continuous numerical features. Categorical features can also take on numerical values. For example, 1 to 12 represents months of the year. 1 and 0 indicates male and female. Still, these values do not contain mathematical implication. Among the two classification algorithms, naive Bayes and SVM, which we have learned about previously, the naive Bayes classifier works for both numerical and categorical features as likelihoods, or are calculated in the same way, while SVM requires features to be numerical in order to compute margins. Now, if we think of predicting click or not click with naive Bayes and try to explain the model to our advertiser clients, our clients will find it hard to understand the prior likelihood of individual attributes and their multiplication. Is there a classifier that is easy to interpret, explain to clients, and also be able to handle categorical data? The answer to this is yes. We have decision tree, which we are going to cover next. In this video, we had a brief overview of advertising click-through prediction.